Okay, day 465 off the grid, and I have indeed succeeded in installing the boost converter battery backup control unit here. So here it is on the wall, just under the charge control gear for the backup batteries, and it's connected directly to the batteries here by this rather meaty looking cable. Although it is not as meaty as it looks. It's actually jumper lead cable, which is copper coated aluminium, looks far thicker than it really is. One thing I want to say about this stuff though, a lot of people probably think that they make the insulation this thick so it looks impressive, so they have a relatively thin conductor inside, but of this big coating of cheap, plastic PVC insulation, so they look like meaty cables. Well, that might be partially true, but I highly suspect the real reason is because aluminium is a lot more fragile than copper. It doesn't handle bending as much. So what they basically do is, because I've made the conductors out of aluminium, they then put a rather large coating of PVC on the outside to try and keep the cable good. This is of course no consequence to me here, because this won't be in motion, it's stationary, and even though these conductors are made out of aluminium, they are totally suitable for the job I'm doing here because they're well thick enough for the currents involved. So there's the boost converter mounted on the wall. I just screwed it to the wall, found some really short screws to use because this wood is really tough, this wood here, so you don't really need to go into a high depth, and you can't anyway unless you drill, so that was cool. Didn't get too overheated putting them in, which was great for once. What else can I say about it? Okay, yeah, I've permanently attached this output lead here. Just goes under the chassis to that terminal block you would have seen on the other video, and just a cable tie wrapped around here to hold it firmly. And that goes down here to these. Now these are called safety plugs, and they're actually not that safe because I've had to actually completely rebuild the way the wires go into them to have any kind of cable clamping. These were bought on some certain sets of jumper leads, which the idea was you put one on one car and one on the other, and when you've made both connections you plug it together. And as you can see, there's an LED on each one to show you if you've got some voltage there. I mean, I could have used Anderson connectors for this, but I had these, so this is what I used. They're quite meaty things. The interesting thing about them is, unlike an Anderson connector, they do have a male and a female connector, but the female connector is actually just a male connector with an extra insert that turns it female, like it's got a built-in gender bender, which if you undo that screw there, you can actually remove it. But anyway, that's enough about jumper leads and connectors. We've got the boost converter running. Oh, one thing I didn't say in yesterday's video, yeah, I use DIN rail. I really like using DIN rail. For one thing, of course you can put circuit breakers onto it, but I've got these DIN rail trays, so that's how I mounted the boost converter. Just a couple of cable ties, held it to the tray, and then I just clipped the DIN rail on. So it's all easily removable if I ever want to, muck around with it. And I may do. So currently it's running. I've set the current relatively modest because when I first turned it on, 15 amps flowed through it. I must have had the voltage set a bit high, and it promptly blew the fuse, but luckily it didn't damage the unit. I've replaced the fuse temporarily with a homemade 10 amp job, which I think is a bit more sensible. 15 amps I think was a bit high. And it is currently pumping, well, that shouldn't be negative, it's just clipped on the wrong cable, but it's currently pumping nearly 2 amps into the batteries with the state of charge that they're at the moment, which is around about 12.6 or so volts. So I'm setting the current quite conservatively. I may come in here later tonight and tweak it up a bit once the batteries are really depleted. The idea was to set a voltage and then use the current hold to regulate the amount of current flowing, but I'm finding that the current hold on this particular unit is really finicky. I don't know if that's a fault in my individual unit or whether it's just the design of this particular boost converter, but the current hold seems to be really finicky, so I'm just going to play around with the voltage pot until I get the right amount of current at the right time. And I would expect that current to increase as the battery gets flatter anyway, and that's basically the idea really. The flatter the main battery gets, the more it can take from the backup batteries down here. So, you know, that's quite an organic process, but I do want to set the voltage more finely and the current hold if I can once the batteries are a bit flatter, so that I'm getting a realistic level there. But I don't want to take too much power out of these backup batteries too fast, because I mean, they're not the greatest. That's why the backup batteries are not part of any main system, you know. They're just there for a cloudy day, a rainy day. That's what they're there for. So I guess that's pretty much it really. Here it is, it works, you know, it's doing the job. And oh, what else can I say? Of course, yeah, this safety plug here, the socket, is connected to the main bank here. I'm going to mount a socket on each of my battery banks, and that was the whole point of using those, so that over winter the batteries I need to boost may change from, you know, sort of month to month or whatever. So I've now got an easy method to just clip off one and clip on to the next. And in fact, until I install permanently wired sockets on these, I can always just use one of the ends of the original jumper lead and just clip on and plug in too, so that's convenient. Or any external battery that I want to use with this. So yeah, it's something I've been wanting to do for a while. I've done it, it seems to work, but we will have to test its effectiveness. See, the currents increase now, probably as the main battery gets a bit low. I'm in fact just about due to switch over to the night batteries, which will give this inverter a rest, and we'll be running off the Xantrix over there for the evening, which is powered by these gel cell batteries. That's the usual procedure. Right, there's one more thing I want to show, and it's nothing to do with solar, but it's something that was also done today. And while I was in the workshop messing around with the boost converter and stuff, Amon was in there too, because Baffy's been out today, and look, she's just come back. There's Baffy, there's my lovely Baffy. Yay. And Amon noticed that there was this meter here, that didn't have a scale on it. So look, he's made his own scale for it. And we actually spent some time today mounting the scale actually inside the meter, behind the glass, and straightening out the pointer so that it actually works. And I've even had to put a test signal into it to check that it does actually work, and it does. As you can see, it's a logarithmic scale. So I wonder what we're going to put this on. We will find a use for it. Yeah, it's kind of cool, wasn't it?
Yeah, but only if it was hitting the glass, it would get stuck up on a level, and if it gets stuck on a level, you have to flick it each time when it gets stuck on that level.
Yeah, but it doesn't stick, does it?
Not anymore, it doesn't.
No, it doesn't stick anymore, no. So we've sorted that one. So better go and get the fire lit before I head out to my SPA meeting, and
but you need to put this meter away somewhere.
Yeah, I'm going to put it away. I'm not going to leave it out there overnight for the dew to get into it. No, can't have that. So there we go. It's day 465 off the grid.